Okay, so today we're going to go over Taylor polynomials, which is a way to represent a function using an infinite series. Now, keep in mind that yesterday, while recording the Maclaurin polynomial video, I said that these two are very similar. That means that today's lesson is going to be a bit shorter than usual. So these two are similar, both Maclaurin and Taylor polynomials. They're similar because of they share the same equation. The only difference being that the value of A in a Taylor series is non-zero, where the value of A in a Maclaurin series is 0. So what it means to be centered at the value A is that, well, it essentially allows the equation to be more accurate to the function. So for instance, if you're solving for e to the power of 3 plus 1 or 3.1, you may write a Taylor series centered at 3 as the value of 3.1 and 3 are very similar. Whereas if you're just looking for anything close to 0, such as e to the power of 0.1, then a Maclaurin series could be more beneficial. Now, it wouldn't be as accurate, seen as the Taylor series can be centered anywhere, but it would be good enough. But today we're going to go over Taylor series. Now, this is the equation for it. If you've watched my Maclaurin series, then you might be familiar with this already. It's very predictable. It looks complicated, but in reality, it's pretty intuitive. Okay, so this is the only practice problem for today. I didn't write more because, again, Taylor series are similar to Maclaurin, and because I was just too lazy to come up with another one. So this is the one we're going to have today. We're told to write out 4 terms in the general term for 4 times e to the power of 2x centered at 3. Now, first, what we have to do is find the 4th derivative of e to the power of 2x. Now, we could use 4 e to the power of 2x. It's just simpler to multiply the 4 later. So, e to the power of 2x. Let's call e to the power of 2x f of x, actually. Now, that means that f prime of x is 2e to the power of 2x, whereas f double prime is 4e to the power of 2x. F triple prime being 8e to the power of 2x. And f quadruple prime of x is equal to 16e to the power of 2x. So what we have to do now is substitute the value of a where it's centered at in place of x. Normally with Maclaurin, we use 0, but since this is Taylor and since a is non-zero, we're going to have to use the value at which it's centered at, which in this case is 3. So f of 3 is equal to e to the power of 6x. And I don't feel like writing all this out. It's pretty intuitive. I'm just going to say 2e to the power of 6, 4e to the power of 6, 8e to the power of 6, and 16e to the power of 6. Pretty simple. From here, we have to write out our polynomial. So let's begin as soon as I erase this, and we might as well call it e to the power of 2x. So e to the power of 2x is approximately equal to f of a, which is going to be e to the power of 6, not 6x, just 6. I don't know why I wrote it as that. But yeah, it's just e to the power of e to the power of 6, yes. Okay, so e to the power of 6 plus, now if you recall from the equation I gave you, the second term is going to be f prime of x, or I should say f prime of 3 over 1 factorial times x. Now, x minus a. Now, this x minus a, we might as well substitute the 3 in for x. Factorial can say the same. F prime of 3 is 2e to the power of 6, so we'll substitute that in quickly. Plus the 3rd term in the sequence, and we're only going to go to our 4th one. And then, of course, we'll write our general term. It's going to be f double prime of 3, aka 4e to the power of 6, over 2 factorial. Now, this can be simplified however It's not, I don't feel like it. Times x minus 3 squared plus the fourth term, which is e triple prime of 3, which in this case is going to be 8e to the power of 6 over 3 factorial times x minus 3 cubed. Now, I don't know why I thought I needed the fourth derivative. I forgot that the first term doesn't require a derivative. So I suppose that that part was unnecessary. Plus dot 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 our general term. So our general term for this polynomial, for this Taylor polynomial, is quite intuitive, I suppose. Yep, that's it. There's no really proper way to find the general term. Sorry, this is actually not correct. I don't know why I put fn to the power of 3. We should have 2 to the power of n times e to the power of 6. Now, this is our general term for our Taylor polynomial. Now, as I said, there's no sure way to, there's no pattern. There is a pattern. There's no equation for finding the general term that I'm aware of. You just have to look at what you've already had and see the pattern and plot it down. But this is the general term, or sorry, this is a general Taylor polynomial for e to the power of 2x. Now, if we want 4e to the power of 2x, then of course we can just multiply this entire series over here, infinite series, by 4. And that is our value. Sorry, that is our Taylor polynomial for e times 4 times e to the power of 2x. That's it, all it for today. If you have any suggestions for future videos, please put them in the comments below. Thank you.